Hello there. I wanted to talk a little bit about the trigonometry review, just real quick, kind of go over a couple of other things that we maybe didn't spend as much time on in case you're looking for a little bit of trig review here. Um, it will really help you in Calculus 1 and 2 and so on as you move on through these. So having an understanding of how to use the reference angles and how to use the unit circle to find the exact values of trigonometric functions is really helpful. So let's take a look here. The first thing I have written down is the 6 trigonometric functions: sine, cosine, tangent, cosecant, secant, and cotangent. You can see there that in the first column, if I were to use SOHCAHTOA, I'm kind of making a break in it, SOHCAHTOA there. Most of you have heard of that. Sine is equal to, here, the opposite over the hypotenuse. You can see it written there. A lot of times I write it as sine is equal to O over H. Cosine is equal to, here, if I'm looking at this one, cosine is equal to adjacent over hypotenuse, so a lot of times A over H. Tangent is equal to my opposite over my adjacent, so that's an O over an A. And you can see that tangent is equal to sine over cosine also, so I have this right here. All right. The reciprocal functions going along with sine, its reciprocal is cosecant. That's equal to 1 over sine. So really all I'm doing is flipping whatever fraction I have for sine, taking the reciprocal of it. So here I could say that's hypotenuse over opposite if I'm looking at sides of a triangle. If I already have found sine's value, I'll just flip it over and take its reciprocal. If you were looking at cosine, its reciprocal here is secant. Again, notice that both start with, or both have a C, one starts and one ends, and both have a S, all right? Not to rule out the one up above, but both have a vowel right here in the middle. I don't know if that helps you or doesn't help you, but that's how you can kind of maybe remember to put them together. I just remember that sine and cosecant and cosine and secant go together. So secant theta is equal to 1 over cosine. That's equal to hypotenuse over adjacent. Again, you can just take the reciprocal of the cosine function if you already know it. And finally, tangent, the one that makes sense for me on the reciprocals, has a reciprocal of cotangent, 1 over tangent. That's going to be a cosine over sine, or an adjacent over opposite if I'm looking at a triangle. All right. The next thing I want to make sure that you remember is, remember we talked in one of the other videos, and I went over, at least in class this semester, if I'm just looking at, wow, that's really sad, circle. The first quadrant of that unit circle, remember this very first angle here is a pi over 6 angle. That's my little angle. My next one, I have 4 of them here that I'm going to draw in. So my next one here is a pi over 4 angle. This next one right here is a pi over 3 angle. And the big one going all the way up to here, this one is a pi over 2 angle. So if I look at the ordered pairs there on the x and y, what I have is 1, 0 down there at 0 degrees. Here, remember, my x values are getting smaller, so I go to root 3 over 2, root 2 over 2. What we could write as a, let me fix that one. What I could write as a root 1 over 2, but I'm just going to write, since root 1 is equal to 1, a 1/2 and a 0. As I count down there in the x values, I'm counting up in the y values. It goes to from a root 0 over 2, or 0, to a 1/2, root 1 over 2. Don't write it that way. A root 2 over 2. The next one's a root 3 over 2 on my y value there, and going up higher. The next one, if I count it up, would be a root 4 over 2. That's the same as 2 over 2, which equals 1. All right. So we have those kind of reference angle values there. And finally, the last thing I want to talk about real quick is, remember, we can tell the sign of various functions by using the whole all students take calculus. Take calculus. And looking at the quadrant we're in. So this right here is quadrant 1. This right here, over here is quadrant 2. Quadrant 3. There we go. And quadrant 4 right here. In the quadrant 1, all trig of theta are greater than 0, so all of them are positive. Over here in the second one, I'm going to key off of the s, so that means that sine theta and its friend cosecant theta, those are both greater than 0, so those are positive. I'd like to, let me write that a little bit different way. Here, let's write this over just a tad. Sine theta and cosecant, that's not a cosine, cosecant theta are greater than 0. Down here, the t, that goes for tangent theta, and its reciprocal cotangent theta, those are greater than 0. And over here, my c for calculus is cosine theta, and its reciprocal secant theta, those are both greater than 0. So that tells me where I have things that are greater than 0. This sort of stuff I went through in a previous video, so if you haven't looked at that, go ahead and take a look at that to review. All right, I'm going to talk about how we can use these to find the values, the exact values of different trig functions. So let's go ahead and start with that. The first example here, I have cosine of 5 pi over 6. So let's go ahead and draw that. I want to find the reference angle there. So here's what we look like. This right here is a 0 angle. This over here is a pi. So when I'm trying to figure out where I'm at, a lot of times I'll rewrite this with whatever I have in terms of my fraction there. So this is a 6 pi over 6. I'm a little bit less than that. So I'm going to be over here in quadrant 2. This angle right here is going to be pi over 6, because I'm just off by a little bit. This was 5 pi over 6 over here. All right. So that's what I'm looking at. I'm going to look at this reference angle. I'm going to go one step further. I'm going to say, all right, I'm looking for cosine in the second quadrant. So if I think about cosine theta, all of them are positive in quadrant 1, all students. So sine is positive in quadrant 2, not cosine. It must be negative. Take is tangent, and calculus goes with cosine. So cosine's positive in quadrants 1 and 4, and negative in quadrants 2 and 3. So what I can do is rewrite this cosine of 5 pi over 6 as a negative. That's because we're right here. Cosine of just a pi over 6. All right. Going back up above, if you want to think about the cosines, those goes with my x values. Those are my adjacent sides. And so if I want to think about that at pi over 6, my x value is a root 3 over 2. And so I'm going to get a negative root 3 over 2. That negative's from in front of the cosine when I went to the reference angle right here. All right. And that's how I use that reference angle there. Okay. All right. Let's take a look at the next one. If you want to pause to do this, go ahead and pause and then restart, and you can check your answer. This one's a little bit different. Here I have sine of negative 4 pi over 3. That means I'm going to go the opposite way around. So instead of going the standard direction where I go counterclockwise, I'm going to go clockwise around. Again, this is my 0 or a 2 pi if you want to. So it could also be a 2 pi. I don't want a fraction between them though, so let's not make it look like a fraction. It can be either one over there. Over here we have pi, and again, I'm going to say that's equal to a 3 pi over 3. It could also be a negative 3 pi over 3 if I'm going this way around. So I'm going to go that way around that far, and then I'm going to keep going. So I'm going to go to a 4 pi over 3. So I'm going to continue to go. This is negative 4 pi over 3 right here. All right, I went the opposite way around. Oh no, don't undo. There we go. All right, Uh, what I want though is I'd really love to look at just this little reference angle right here, and that's going to be a pi over 3 angle. All right. Again, I'm going to take a look at what quadrant I'm in so I can tell whether my sign is positive or negative there. So thinking about sine theta, all, first quadrant, everything's positive. Students, sine is positive. Take in calculus, sine is negative down there in the bottom. Makes sense, my y's are negative. So let's rewrite because I'm again in quadrant 2. So this time I'm going to stay positive. I'm going to get that this is equal to sine of a pi over 3. This is my reference angle. It's positive, all right? If I think about sine of pi over 3, again, you can go up and look at your unit circle if you want to. Sine is going to be your y value. It's how high up I am, the opposite side. So that's going to be a positive root 3 over 2. So I don't change the sign on that to negative. I have a positive root 3 over 2. All right. Taking a look at the next one, I have a sine of a 7 pi over 4. And if you'd like to pause and try and take a shot at that, that would be great. I'm going to go ahead and start to draw. So I'm going to draw where it's at and figure out which quadrant it's in. So here I have 0, here I have pi. That's going to be equal to 4 pi over 4. So I go at least that far around. I'm going to keep going. I know that if I went all the way around the circle once, I would have an 8 pi over 4. That would give me all the way around. So I'm just a little bit less than that. Sorry about that, folks. Just a little bit less than that. Just right here, this is going to be 7 pi over 4. All right, and that means that my angle over here, that's my reference angle, is a pi over 4, because that's all that's left if I look at the 8 pi over 4, minus the 7 pi over 4. All right, that means I'm over here in quadrant 4, so let's take a look at sine in quadrant 4. So if I'm looking at sine theta, and just real quick, als, so it's positive there. Students, that's positive there. Take, it's negative here. Calculus, it's negative here. So if you want to write the all students take calculus, go for it. But sine down there in quadrant 4 is going to be negative if I use my reference angle. Okay. So here's what I'm going to do. I'm going to say this is equal to the negative of sine of pi over 4. All right. Sine of pi over 4, it's actually the y value at the pi over 4 angle. So if I pop right back up here, we can see that pi over 4 angle is this one. It equates to these. And my sine and cosine are actually equal there. That's kind of that lovely 45-degree angle. So let's bring that pi or root 2 over 2 down here. I'm going to have a negative, oh, it moved, negative root 2 over 2. All right. So that's going to be my sine of 7 pi over 4. All right, let's take a look at the cosine of negative pi over 3. Again, the negative there on this, within the argument there with the cosine, it's telling me to go clockwise around instead of counterclockwise around. So let's go ahead and make a nice little axis for us. These ones I like. I'm just going to go a negative pi over 3. I haven't gone very far. I'm just going this way around. But that also means that my reference angle is also a pi over 3, because this is the same as negative pi over 3. So that kind of helps me out. All right. Back again to my all students take calculus, this time for cosine of theta. I know I'm in quadrant 4 here, right? So I have all, that's positive, students is negative for cosine. Take, tangent is positive, so cosine is negative, and calculus, there my cosine again is positive. So this is going to be equal to, I'm going to be using this one, equal to cosine of my pi over 3. And if you go and take a look at your unit circle there, or you take a look at whatever you drew out, look up on your paper, what you should find is that you get a 1/2 on that one. All right. If you want to put a plus sign in front of there, feel welcome to. All right, let's do a couple more. Here I have a tangent of a 3 pi over 4. So these ones are a little more work because I've included some that have either the reciprocals or the tangent. So tangent of 3 pi over 4, let's take a look at where that's at. So again, this is 0. This is pi over here, and then this is 2 pi, right? If I'm looking for 3 pi over 4, let's turn this into a 4 pi over 4, just so I know where I'm at. And again, I think we had one sort of like this earlier. This is my 3 pi over 4. So my reference angle here is going to be a pi over 4, right? I'm in quadrant 2, so let's take a look at what happens to sine in quadrant 2. So if I'm thinking about sine theta, I have all students, so sine is positive there in quadrant 2, take calculus. So I'm going to have a positive. Oh, wait, we're not looking at sine. Hold on a second. I don't know. I'm looking at sine. Let's do tangent. Tangent theta. So let's try this again. All right. We have everything's positive in quadrant 1. Students here, that's going to be a negative for my tangent. Take, that's a positive for my tangent. And calculus, so a negative for my tangent. All right. I'm in quadrant 2, so I'm going to be negative on my tangent value. So this is going to be equal to a negative tangent of my pi over 4. Now, if you're not sure what happens, pi over 4 angles are actually my favorite for tangents. You'll see why in just a second. This is equal to negative of sine of pi over 4 over cosine of my pi over 4. All right, keep that negative with you. If you take a look at your unit circle, you'll note pi over 4 is where sine and cosine are the same. That's like that 45-degree angle. So I get a root 2 over 2 for my sine and a root 2 over 2 for my cosine. Now, those two are the same, so I have root 2 over 2 divided by root 2 over 2. It's still negative, so grab that negative, but it's going to be a negative 1 for you. All right. Keep an eye on that. Those ones aren't bad. If you remember the pi over 4, you can skip straight from here to here. All right, if you remember that sine and cosine are the same at that angle. Let's take a look at a secant. See, I have a secant of a negative 11 pi over 6. So let's again draw out this 11 pi over 6. I'm going to try and remember I'm a secant. So again, I'm going to do my 0 here. This is, I'm going to go backwards around. So I'm going to make this a negative pi right here. That's going to be a negative 6 pi over 6. So I've gone at least halfway around the circle. I'm going to keep going. If I'd gone all the way around, I would have been at a negative 2 pi. That's going to be equal to a negative 12 pi over 6. So I'm just a little bit short of that, just a pi over 6 short of making it all the way around once. So this is my negative 11 pi over 6. It's really hard to read. And right over here, this angle right here is just a pi over 6. So I can say this is equal to secant of pi over 6 if I want to think about it as a positive thing. I haven't changed any signs. All I did was instead of going this direction around, I said, let's go our normal direction around and put it in standard position. All right. Next step, secant. Secant is 1 over cosine. Notice they both have an S and a C, and they both have a vowel in the middle. So 1 over cosine of pi over 6. So I'd like to know whether cosine is positive or negative, but since I'm in quadrant 1, everything's positive, so I'm going to stay positive here. So I don't really need to change much when you're in quadrant 1. You don't need to look at that little table like what we did up here. All right. Cosine of pi over 6. that is the one that is going to be the very first one you run into. So I'm going to have a root 3 over 2 here for my cosine value. Go ahead and take a look at that if you want to and double check yourself. If I do that, then I know that's going to be, well, let's look at how we do this. If I want to get the fractions out of fractions, we don't really like those. I'm going to multiply the numerator and denominator by the same thing, and I want to get rid of that bottom fraction, this one right here, this 2. So I'm going to multiply by a 2 over 2, and what we see happen there, if I unhighlight that part, is this 2 in the denominator cancels with this one. The other one stays in the numerator, and I multiply straight across. So I get a 2 over root 3. I'm fine with that answer. Square roots in the denominator don't bother me at all. If they bother you or you're asked to rationalize, remember we multiply. We could also multiply numerator and denominator by a root 3 over root 3. And that would give us a 2 root 3 over a 3. I don't know. I can't say it looks a lot better. I'll take either one. So if you like rationalizing, go for it. If you don't, then don't bother. It doesn't bother me at all. All right. All right. Tangent of negative pi over 3. Go ahead and pause and give this one a try on your own. See if you can draw it, figure out where it's at, and whether or not you're positive and negative. And then let's set it up. All right. So if you paused, or if you didn't, we'll do it together either way. So if I'm looking at this one again here, I'm going, this negative pi over 3 says I'm going this way by a pi over 3. That means that my reference angle is the same angle. It's still a pi over 3 angle. All right. So I'm going to look at my tangent at pi over 3. Let's take a look at the sign in front of it though. So tangent theta. If I'm looking over there in that fourth quadrant, I have all students, nope, take, yes, that's positive there in quadrant 3. Calculus is, tangent is negative in quadrant 4. So I'm going to go ahead and put a negative sign in front of that. All right, so this was in Q4. Alrighty, so if I find tangent of pi over 3, a little bit more work. These ones I don't remember. I'm going to say negative of sine of pi over 3 over my cosine of my pi over 3. Sine of pi over 3, it's going to be the big one. So I have a negative root 3 over 2 over 1/2. All right. I have 2's in both the denominators. Your choice. You can cross out those 2's in the denominators, or if you want to, multiply both my numerator and denominator by a 2, and you can see those cross out and those cross out. And what I'm left with is just a negative root 3. All right. The 1 goes away, divided by 1, it doesn't matter. All right. Well, it matters, but it doesn't impact my negative root 3. All right, let's see. I got a couple more. I'm going to go ahead and keep going. If you need to pause or take a break, pause and take a break. All right. The next one here, I have a cotangent of a negative pi, and actually I changed this one. So I forgot to change it on my thing. Let's change this out. Let's try cotangent of negative pi over 2. I'll explain why in just a minute. We can talk about the negative pi in just a second if you want to. Here, so if I'm looking at this one, let's go ahead and draw it. Cotangent of negative pi over 2. I'm going this way around. This right here is pi over 2 angle. So I'm right on this axis right here, all right? This is my basically angle or vector that I'm going to. So this is pi over 2 right there. Or negative pi over 2. It's either one, all right? So what I'm really looking at here is if I went positive way around, I would have a 3 pi over 2, all right? Let's see. So I have a cotangent of a 3 pi over 2 if you want to go the positive way around. This one's what we call a quadrantal angle. So we need to look at what's happening on that quadrant line. So I'm going to rewrite it. A cotangent is equal to cosine of a 3 pi over 2 over my sine of a 3 pi over 2. All right. Cosine is my x value. So if you look here, if I come all the way around, let me grab a little highlighter. If I've come all the way around to here, I'm on this thing. I've gone nowhere in the x direction. I haven't moved this way at all. So my cosine is going to be a 0 there. And my sine value, I'm down here, right? And so it's going to be a -1. All right, 0 divided by -1, no problems at all. That's equal to a 0, and that's going to be my answer there. All right, the reason that I changed that one, if I kind of cordon it off, is that if I had cotangent of a -pi, then what I'd be looking at is going around like this. My angle would be right here on this axis. All right, that's the same as cotangent of pi. If I came around like this, that's fine. Then I have a cosine of pi over a sine of pi. That's all good until we do this part. Cosine of pi is equal to a -1, and sine of pi is equal to, well, I haven't gone anywhere up or down, so it's equal to a 0. Can't divide by 0. All right, so this does not exist. All right, so just to go over that one so you know what happened there and why I changed it. Let's see, we've got two more. Kind of interesting one. The last one, or not the last one, the second to last one here is a cosecant of a 7 pi over 6. So let's draw that baby out. I'm going positive direction around here. So let's get the angle first. Here I get a pi. Here I get a 6 pi over 6 is equal to my pi. All right, so I'm going to go a little bit further. This right here is 7 pi over 6. That means my reference angle is just a pi over 6, right? All right, perfect. So I'm going to say this is equal to cosecant of, I don't know if it's positive or negative yet, so let's hang tight a second. All right, let's look. So let's do cosecant theta, and that has the same sign as sine of theta. So let's take a look at sine theta, because this is going to equal 1 over sine of 7 pi over 6. So let's figure out where I'm at as far as negatives and positives before I go to the reference angle. Let's see, I have all students, so second quadrant's positive, take calculus. That means both of those third and fourth quadrants are going to be negative. Here I'm in Q3, and so I'm going to be negative. So as I write it with the reference angle, I'm going to have a negative 1 over sine of my pi over 6. All right. Sine of pi over 6 is going to be a 1 over a 1/2. That's my pi over 6 value there for sine. That's how far up and down. You can see that my y value is smaller than my x value when I draw that there. So let's get the fractions out of fractions, multiplying both numerator and denominator by a 2. This one cancels, and I end up with a -2 on my answer there for that. All right, last one. This one's fun. I like this one. Hopefully that one looks good. Pause again if you want to. Try and give this one a whirl. It's a little bit different. All right. So here's what I got. I have sine of 11 pi over 3, and that's a really big looking number. So let's take a look at it. I have 0 here. I have pi. That's going to be equal to a 3 pi over 3. So I've gone that far around, right? Nice little plop there. All right. Over here, I have a 2 pi. That's equal to a 6 pi over 3. So I've gone that far around. So I've gone all the way around once. Actually, let's leave that part like that. So I've gone all the way around like this. All right, it connects it now. All right, we're going all the way around like this once. So let's rewrite this. I'm going to take a 6 pi over 3 off of this. So this is equal to sine of 11 pi over 3 minus my 6 pi over 3, because I'd like to have it just once around. So I'm going to get a sine of a 5 pi over 3. All right, so let's see where we're at now. I'm going to erase the first loop around because it doesn't matter. All right, 5 pi over 3. That means that I've gone the 3 pi over 3 here. It really wants to do that curve, right? A 4 pi over 3 would be right down here. The 5 pi over 3 is way over here in quadrant 4. All right, so I'm right about here. This is going to be 5 pi over 3. That's the same as 11 pi over 3. All right. The only difference would be that on 11 pi over 3, I went like that. All right. All right. So if I'm looking at my reference angle here, you notice I'm just short of that 6 pi over 3. So I've got a pi over 3 left over here. That's my reference angle. So I'm in quadrant 4. All right. Let's take a look at sine theta. And if you were stuck on that part and you want to take a break for a second, see if you can find what your, whether it's positive or negative and what your value is, go for it. If we're ready to do that, then what I'm going to do is all students, positive in quadrant 2, take in calculus, it's negative if I'm below the x-axis. So in quadrant 4, I'm negative. So let's go ahead and write it that way. Negative sine of pi over 3. All right. I know that sine of pi over 3, let's bring that negative sign in before it gets lost. Sine of pi over 3 is going to be a root 3 over 2. So I get a negative root 3 over 2. And that should be my answer there. All right. I hope this was helpful. I know it was a little longer than some of the other videos. If you have any questions, please let me know. Happy to help, but hopefully it kind of clarifies how we use those reference angles in order to find the values of different ones just through a lot of examples. So have a great day, and I'll see you soon.